Hey guys, good morning or afternoon or night, whenever you're watching this. So today is Unit 1, Lesson 9, Part 2. So we're turning to page 46 in our workbook. So if you're not there yet, go grab it and get going, but pause me during that time. What we're going to do is we're going to do the same learning target. I know it's been like 4 days of it, but I hope at the end of the 4 days we are truly feeling a bit better and really diving into these lessons. So, yes, there will be a little bit of a formative assessment today on this stuff. I'm going to give you one problem, really have you dive in on a Jamboard and show me your understanding. All right, here we go. So, page 46. Sometimes it is crucial to be able to define one quantity in terms of another by thinking about the physical scenario that is being described. Exercise number 3. Remy buys hot dogs and sodas at a concession stand. I'm not going to highlight anything yet. I can get the gist of these buying hot dogs and sodas. Oh, but here comes some important stuff. The hot dogs cost $2.25 each, and the sodas cost $2.75 each. He buys a total of 17 items. Okay, so he buys a total of 17 items. If Remy, so here's our example where it gets us to start thinking. If Remy bought only two hot dogs, how much total money would he have spent? So, two hot dogs, and that means if we have 17 items, he buys 15 sodas, right? Okay, well, let's figure out what that would be. So we would have two hot dogs times $2.25. They each cost $2.25 plus 15 sodas times $2.75. Okay, let's type those in. So we have 2 times $2.25. That's going to give me $4.50 plus 275 times 15. That's good. Whoa, that's a lot of money in soda. $41.25 in soda. So adding those two up, we get $50.25. So that's what he would have spent if he had only bought two hot dogs. Pretty interesting, eh? Okay, so part B. Let D represent the number of hot dogs. So I'm going to bring that out. Okay, I want to make sure I really do understand what my variable is. Give an expression for the number of sodas he bought in terms of D. So if he bought D hot dogs, then the sodas have to be 17 minus D. That's the number of sodas because we know the total of the items, and now we're calling hot dogs D. Then 17 minus D minus the number of hot dogs would be the number of sodas. So here we go. That's getting us set up for the next part. If Remy spent a total of $40.75, so there's our total that he spent on the 17 items, algebraically determine how many of each he bought. So what we're going to pull in here is kind of this expression, okay, and setting that equal to that, except we can't use 2 anymore and 15. We're going to use the generic amount of hot dogs and the generic amount of sodas, so that way we can plug in and find out how many that he really bought. So instead of 2, we're going to use D, because that was the hot dogs. So the number of hot dogs times $2.25 plus the number of sodas, which we just said was going to be 17 minus D, times what is the price of the soda? $2.75. Okay. And when he buys that amount of each thing, he spends a total of $40.75. So a little bit messier because of the decimals, but we got this. Okay. We're going to flip these two around. We're going to make 225 our coefficient. We're going to make it look prettier. Now we have to distribute through. So let's do $2.75 times 17. I'm getting $46.75. And then $2.75 times negative D, that's going to give me negative $2.75 D. Okay? And that equals $40.75. Okay. Our next step would be to combine like terms. I got my 4 here. Getting a little bit ahead of myself in my brain. So I see some D's here that are alike. So when I do $2.25 times minus $2.75, I get negative 50 cents D plus the $46. I think it's going to be okay though that that's negative. We might be questioning it, but if you think about balancing the numbers, there's more here than here. So when I move it, I'm definitely going to have a negative there. Let's move that over. By subtracting, we're doing the opposite operation. It looks like we're going to get negative 50 cents D equals negative 6. So now, even though our coefficient is kind of crazy, we're still going to divide by it. Remember, Mrs. Brown said no matter what the coefficient is, you're going to divide by it to get the variable alone if it's being multiplied. And that is multiplication right there. We're dividing by that negative 0.50. I'm just going to type it in because I got a little bit of a problem wrong the other day, I think, on my video. All right, so D equals, I'm getting positive 12. So that means he bought 12. If D is hot dog, he bought 12 hot dogs. He bought 12 hot dogs. And, well, let's see, 17 minus D is soda. So 17 minus the 12 hot dogs. 17 minus 12, 5 sodas. Okay, and that's our answer. All right, wow. Okay, pause it if you need a moment to catch up, and then we're going to keep going. All right. Exercise number 4. The rectangle below has a perimeter of 29 feet. Super important information. So when I add up all the sides, going all the way around this rectangle, it's 29 feet. Its length is 3 feet less than 4 times its width. Length is 3 feet less than 4 times its width. Part A, let the width of the rectangle be x. So let the width be x. So I'm going to pull that out and I'm going to write let x equal the width. Okay, so I can label my triangle too. Here's x and here's x. So now it says the length right here is 3 feet less than 4 times the width. So 4 times the width minus 3. Remember that 3 feet less than is that flip-flop. It's that takeaway. So if this side is 4x minus 3, so is this side. We know on a rectangle, opposite sides have the same length. Write an expression for the length in terms of x. Label on the diagram. So we've already labeled, and we've already written the expression for the length. There it is, right there. So we've done our work ahead of knowing to do our work. Let's go to B. Set up an equation. There's that command. Based on the perimeter and solve it for the value of x. State the value of both the width and the length. Okay, so our commands are to set up an equation and solve it, and then state the value of both the width and the length. So here we go. Let's set up an equation. So again, so going back to the start, it said perimeter is 29 feet. So we have x plus 4x minus 3 plus, I'm just going around grabbing, x plus 4x minus 3. You can grab in any order. You just have to keep yourself organized when you're grabbing. And that all equals 29. So put in our balance beam, and we'll combine like terms. Remember, this is 1x. This is 1x. So we have x plus 4 plus 1 plus 4. 1 plus 4 plus 1 plus 4. I believe that gives me 10 x's. Let's do our numbers now. Negative 3, take away 3 more. When I type it into my calculator, I'm going to get negative 6. Bring down that equals 29. Let's add 6 to both sides. We get 10x equals 35. We're going to divide by the coefficient. Doesn't look like it's going to be pretty, but when I divide out, I get 3.5. So the width is 3.5 feet. And the length, now we actually have to solve for the length. So we take our x and we plug in to the expression for the length. 4 times the x times 3.5 minus the 3. Let's type that in. 4 times 3.5 minus 3. I get 11. The length is 11 feet. Bubble cloud. Great job, guys. Way to really persevere through that video. It's a lot, I know, but I believe in you, and I think we can really pick apart these words and find some meaning and patterning in the linear equation setup. Okay, see you soon.